Testing. Good morning, Fancy Meat computers. How's everybody doing today? I'm doing well, thanks for asking. Even though you didn't yet, because it's impossible for me to have received that information so quickly. But anyway. Looks like everything's working. Excellent. Alright. Cool. Let me just check our announcements feed, see if we got any announcements to talk about today. Let's see. Yeah, well, so we finally sorted out who's doing what tutorial. There was a bit of confusion pertaining to the Friday, the T2 tutorial. I'm doing well, thanks. Awake is as good as you can be expected to be, I think. So, for those of you who are not in the T2 tutorial, don't worry about this because this doesn't pertain to you. But for those of you who were, there was a slight problem with the scheduling of said tutorial. Originally, this tutorial didn't even show up in my Mosaic feed. You may remember me mentioning it, and it turned out, I think, that when it did show up in my Mosaic list of courses that I have, it showed up with the wrong time slot. It was off by 2 hours. So this was pointed out to me, and I had to, we have gone to great lengths this semester to ensure that every tutorial section has a TA. So I hope you all appreciate it. But yes, so where can you find the slides? The slides are under content, and then just look at whatever topic we're on under here. Very simple. So, yes. So everybody should be, going to their tutorials this week. Of course, T4 already occurred, so you guys should all gone to your tutorial on Monday. For the rest of you, your tutorials start this week, so please go to your tutorials and have fun. Tutorials kind of take on a new significance when they're the only thing that you're doing in person, eh? So, anyway. So, that's, I think that's about the long and the short of it. Yes, yes, yes. Yes, 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 yes. Indeed, indeed. Oh! Okay. Virtual office hours. Yes. So, let me explain the new regime. I have decided that it seems reasonable for me to have virtual office hours. Given that a number of you are in different parts of the world. So this is how I'm going to do it. I'm taking my 1:30 to 2:30 time slot on Thursdays, and I'm stretching it out so that it's now 1:30 to 3:30 on Thursdays. And during that, I will be taking appointments in both MeetSpace and Cyberspace. So if you'd like to show up in MeetSpace, come in MeetSpace. If you'd prefer to show up in Cyberspace, I will have my computer open and the call running. So I'll be able to, hop back and forth between the two, which is kind of emblematic of the semester as a whole, I think. But anyway, so that's the plan for virtual office hours. Hopefully that all works swimmingly. What do you generally do in the tutorials? The tutorials are supplementary material to the lectures, which are generally meant to reinforce the lecture material. Most of the time in the tutorials, we will be covering things that extend the lecture material. So new and original content will be covered in tutorials. This week in tutorial, I believe the TAs are going to show you how to get practice. how to get practice with the types of programming problems that are appropriate for your level of absolute introductory beginner. So if you're already an expert Python programmer, you probably need to have the same level of interaction with the tutorials as you do with this class, but there may still be some very interesting things in there for you guys. So, yeah, the virtual tutorial will be on MS Teams. The in-person tutorials will be in whatever room you've been assigned. I think it's all in BSB 249. So yeah. So the office hours will be held in ITB 102. That's my room. So see you there. Anyway, so we were talking about flowcharts, and just to recap, so there are no pre-videos for tutorials. There's no pre-video. Will tutorials be recorded? The virtual one will. The in-person tutorials will be in person. So there you go. Good. So, just to recap the stuff that we were talking about last time. We were talking about flowcharts. Flowcharts are an extremely good abstraction. They're a good model for computation if you're just trying to slide yourself in to the whole programming thing. One more question about tutorials before we get into it. If we are doing fall online, then you should ignore the tutorial time slots in your calendars and only attend the virtual one on Friday. That is correct. That is correct. So with respect to the flowcharts, we've got basic instructions, which are boxes. These are things such as assignment statements and print statements. In order to sequence instructions, you put boxes together with arrows between them. Sometimes we will have a dot at the beginning and at the end to indicate the beginning and end of an algorithm. Normally it's pretty obvious, though. It's the first thing that has an arrow going into it is the start, and the last thing with an arrow coming out of it is the end. So, in addition to statements, we also have conditionals. So, when the flow through the flowchart hits one of these diamond-shaped blocks, you have an option. Which path you take will be determined deterministically by the condition that is inside of that block. If the condition comes out true, then you follow the yes branch. If the condition comes out false, then you follow the no branch. This first construction is the if-then construction. So, the statement S only executes if the condition comes out true. If the condition comes out false, then no statement is executed, and flow continues on through the program. The alternative to this is the if-then-else construction. In the case of an if-then-else, the statement S is executed on the condition coming out true, and the statement T is executed on the condition coming out false. Hence, if B, then S, otherwise T. These are extremely important to understand. So, the third is while loop, the quote-unquote while loop. While loops are extremely important to understand. Loops in general are like the first hard thing that you need to know about programming. the difference between a while loop and an if statement is, rather than having the flow of the program continue on to whatever the next statement is once it's finished with the S block, control is actually returned back up to before the condition was tested. This means that the condition, as long as the condition is true, this program is stuck in a loop. This is why they call it a while loop, because execution loops around until you hit the false case and exit from the loop. Pardon me. So, let's break this down. Let's talk about basic instructions. The basic instructions of flowcharts are those which the underlying machine has for changing the state. You have, generally speaking, assignment. This is not Python syntax, incidentally. This is math syntax. Assignment in math looks colon equals, but in Python it's just an equals sign. So let's bring up the Python interpreter. So that's probably going to be too small. Let me bring up a terminal. See if I can increase. Zoom in. That's good. That would be a little better for reading, right? Can I zoom in again? I can zoom in again. All right. There we go. That good for viewing? Yes, it's interesting. Like, it seems that there is a very wide disparity in the way that various professors run various courses. My philosophy with respect to running this course has always been to try to run it as closely as possible to the kind of course that you would take if you were in person. So come to the lectures, come to the tutorials, do the assignments, write the test, write the exam. And if you're not following the material very well, do selected extra exercises on your own volition. Good. So an interesting thing with that you can do with Python, which I don't think that I've shown you guys yet, is you can actually type Python commands directly into a command line interface. You have access to this via Windows PowerShell if you've downloaded the Anaconda distribution. So Python 3, you can see I am now inside of Python. This triple arrow means that this is the Python command prompt. So assignment. Assignment is just something like x is equal to 4. If I ask for what the value of x is by printing it, it gives me 4. So, and if y is 7, there we go. Y is 7. X plus y is 11. 5 plus 7 times 8, 62. This is using Python as a calculator, but you can also enter like full Python programs in the in this environment. The only trick is I wouldn't recommend doing this like writing your assignments this way, because when you're writing stuff in the interpreter like this, you have to get each line exactly correct as you enter it, or else you just have to retype the whole thing, which is annoying as hell. So, if you're doing anything that's longer than like 2 or 3 lines, I would recommend doing it in an actual file rather than just doing it into the interpreter. But this is, this is still good for demonstrating. I'm going to use the interpreter, for demonstrating a lot of different things. Throughout this course, because it's just kind of faster and easier for certain types of examples. But just keep in mind, anything that I enter into this interpreter is 100% a valid Python program that you could just copy and paste into a file and it would just work. So, like for example, if 2 is equal to 1, print, nah, bro. Else, print, yeah, bro. Yeah, bro. Because 2 does not equal 1. There you go. So, that's a good question. So the question is, how does y print without a print statement? So, when you're inside of the interpreter, whatever is entered, whatever is the final result of the calculation is printed by default. Yeah. This is not done, well, no, this is not done by default in a Python file. It's just a sort of a thing that the interpreter does, which reduces the amount of typing that you have to do. So, good. So this is how it works. Very quickly, I'll show you multiple assignment, although, quite frankly, you'll see it once and probably never use it again. So if you want to do multiple assignment statements on one line, you can use commas to separate things. So x comma y is equal to 6 comma 7. X is 6. Y is 7. There you go. In addition to assignment, you'd also have your regular complement of arithmetic operators. You know, addition, subtraction, division, and multiplication. There are a few interesting ones that are a bit different, but yeah, you can't put links into the chat on YouTube, just so you know. There are a few ones that are different that are probably ones you've never heard of before, like modulus, but we'll get to that in topic 2. So, here is a flowchart for the median of 3 numbers. The median is the middle number of 3 numbers. So the median of 3, 7, and 2 is 3. This flowchart, doop-a-doop, gives you a program which calculates the median of 3 numbers. It calculates the median of, at most, 3 numbers. So that's, you know, as programs go, this is not a powerful one because it's not a general purpose solution to that problem. But let's do an implementation of it in Python anyway. So, doop, let me just see, where am I? I'm in 2MP3. 1MD3. 1MD3. Hi-ho, Viderio. Get it. Topic 1.py. That'll do. So, I'm just going to eliminate a few print statements by commenting them out. And we shall create our median function. So, what does it mean by changing state? So changing state just means we've changed the values in the variables. The values that are contained in the variables are the state of the program. So when we do an assignment statement, that changes the numbers that are stored in the variables, which changes the state of the program. There you go. Median of 3 numbers, x, y, and z. If x is less than y, that we do one thing, if so, and something else in the else case. So, following the yes branch, our next condition is x is less than, or z is less than x. If z is less than x, there we go, we do something. Otherwise, we do something else. On the yes branch here, we say m is equal to x. On the no branch, we have one more condition to test. If z is less than y, m is equal to z. Otherwise, m is equal to y. See the speed with which I'm able to pop this off? When you type Python 3 into PowerShell, it takes you to the Windows... Oh. No, okay, on PowerShell, just type Python without the 3. Yeah, in PowerShell, it's just Python. But yeah. I'm pretty sure anyway. So, and that concludes the yes branch for this program. Now for the no branch. If x is less than z, else do something else. On the yes branch here, we have m is equal to x. Otherwise, if z is less than y, m is equal to y. Otherwise, m is equal to z. And this almost completes our program. Because this is a function, in order for the final value to be given back to the thing that calls the function, we need to include the return result. So return m. M is the final value. It's the thing that we're trying to calculate, and therefore we say return m at the end. There you go. So, for example, if I wanted to find the median, print the median of 3 numbers, say this number, that number, and this number, then Python 3 topic1.py, the median number is 832,845. There you go. Yes. Yes. There's so the there are absolutely different ways of doing this. One of your colleagues in the chat is suggesting sorting, assuming the input is a list, sorting that list, and then finding the middle element. That is correct as the general algorithm for finding the median of an arbitrary number of numbers. However, at this level, we're just, like, I'm just trying to show you how if statements work. We're going to get into that type of thing a little later on. A lot of people don't even know what a list is in this class, so there you go. Yeah. It's important to know where things go, but yeah. This is, yeah. Yeah, thank you. I've been vindicated by the chat. So, there you go. So, there are a couple of things to talk about with this, which are not super important. One, you can annotate flowcharts. So one of the advantages, which compiler am I using? Well, let's see. Python 3 version. It's Python 3.8.10. That's the compiler I'm using. Yeah. So someone in the chat has said the colons are required. The space doesn't matter. The space does matter. In Python, the space definitely matters. But yeah. So when you're doing a flowchart, one of the things that you can, one of the advantages that you have is that you can say things about these different branches. Like, for example, if you're on this branch here, you can definitely say that x is less than z and that x is less than y. These are kind of the idea of invariance, right? These are kind of this is the idea that as you progress through a program, different conditions will hold. There will be things that are true about the data that weren't true before. This is actually a very, very important concept in programming, but one that you probably won't get for a while. This idea that, the data will have properties depending on the structure of the program. So in general, with flowcharts, you can do this sort of thing, but just be careful not to over-annotate, because things can become a fractal spreadsheet nightmare very quickly. So I'm going to skip these. I'm going to skip this question because we did a Python implementation of it. So let's move right along. Basically, it's like, what's the maximum number of operations needed through this? And it's 4, because look, 1, 2, 3, 4. That's the max. Haha, there we go. Very fun. So let's. Oh, indentation. Yes. So, yeah, white space is kind of sometimes tricky, but in general, in Python particularly, indentation and some other, it's kind of it picks and chooses which space has semantic content. Like, it doesn't matter how many spaces you have between things, but it does matter what level of indentation things are at in Python. So let's talk about this new other example, which is an example of a loop. So actually, yeah, that's a good point. So in Python, the way that we tell if something is inside of something else is we set it to the right level of indentation. So this is the beginning of a function. Everything that is inside of this function is indented one space, or one tab. It's one tab over, and that means it's inside of this function. So everything from here down to there, that's all inside this function, right? This print statement at the end is not inside the function. It is exterior to the function. That's how we can have a call of that function with these values and get a result. Similarly, everything at indentation level 2 in here, that's all inside of this if statement, specifically the true branch of this if statement. This else, because it's back down to level 1 indentation, that breaks the level 2 indentation here. So it ends that which is inside of this if statement. And then it starts up its own case, right? And this is, you can do this all the way down. Let's see. Yep, good. Can bubble sort be used to find the median? There are much better sorting algorithms than bubble sort. Yes. In VS Code, it shows you thin lines, showing you if it's inside or not as well. Well, that can be helpful, yes. But, yeah. Anyway, so let's talk about this flowchart. This is a flowchart for finding the minimum and the maximum of a series of numbers. So when I do an implementation of this, I'm going to have to do a list, unfortunately, even though we haven't really covered lists yet, because, the alternative to that is to have a million input variables, which I don't really want to do. So the idea here is that we have a set of integers ti, and for I between 0 and n, these represent a series of temperature readings. The things that we want to output are the minimum and the maximum temperatures. So this question kind of gets into the idea of initial conditions. So let's start a new function, def min-max. We will take a series of temperatures t, and I think that's all that we need for it, actually. So t is going to be a list. Shell sort is the bomb. Quick sort is pretty good, too. library sort is interesting. So, flowchart. There we go. So, the first thing that we do is we take I, min, and max. We create variables. So I is equal to 1, min is equal to t at 0, and max is equal to t at 0 as well. So the way this algorithm works is we have a condition testing to see if I is less than n. That is to say, we're testing to see if we're through all of the elements in our thing, all of the elements in our list. You'll notice that we've got all this stuff in the middle, and then at the end, our control flows back up to this conditional. We can therefore conclude that we need to use a while loop. So while I is less than n, we shall do some stuff. So the first thing we do is we test to see if t at I is less than the minimum. So if t at I is less than the minimum, then it must be the new minimum. So we set minimum to be ti. We overwrite the existing value of minimum with the value that we just found that's less than minimum. Prof, I recommend you use any specific code editor or VS Code. So for your assignments, you can actually just use the Jupyter environment. When you do an assignment, the code block in the assignment document is a fully fledged Python editor. So I would recommend using that. All you have to do is hit Shift-Enter, and you can execute code directly in it. Actually, you know what? I think I'll show you guys just very quickly. Forgive me this brief tangent. So Jupyter Notebook. So that will bring up, that brings up something like this. New Python 3 notebook. Markdown. So blah, blah, blah. This is a code block, right? So let me do this in this code block, actually. So let me just copy over my progress. There you go. Yeah, so this block also shows you the indents, which is helpful. Unless, oh well, it does if the tabs came from outside. Python can sometimes be like tricky about its tabs, so whenever you're in a new environment, you should always replace the tabs. So, the next thing that you want to do, if you see right here, we have a simple if-then statement. This is an if-then-else, and this is an if. So, if t at I is greater than the maximum, we wish to set the maximum to ti. Then, once everything is finished, I is equal to I plus 1. This is the most important line in the whole loop. Without modifying I, it will be impossible for I to ever exceed the value of n. Therefore, this condition will never be false. And if this condition is never false, then the computer will spend forever executing this loop. Literally forever. So that is what's called an infinite loop. So you always, always, always have to remember to modify these guys. You have to modify whatever variable you're using to count. But yeah, anyway. And then at the end, we return min max. So let's try it out. Let's make a list of numbers. There we go. Print min max t. Shift-Enter to execute. I've got a name error. Haha. Let's see. Name n is not defined. Oh, yeah, that makes sense. So n is defined as being the it's the length of t. We're gonna, again, if this is a little confusing, don't worry. We're gonna show you how to do these things. So n is just the number of elements in the... It's the number of elements in the list, right? And we can find that automatically by taking the length of t. So, Shift-Enter, there you go. Our minimum value is 1, our maximum value is 82. 1 and 82. Therefore, everything works. Yes. So there you go. Again, I'm going to kind of skip through a couple of slides because we did an implementation of it. Although it might be useful to do a trace of this program for the loop. So, print max is equal to max. Print min is equal to min. Print t I is equal to t at I. Let's execute that. And, oh, let me just put something in to put a separator in. There we go. So for each iteration of this loop, this is how it looks. So min and max start off as 9, which is right here, right? Ti is 3, so the minimum gets set to 3, right? As every time we find something that's less than minimum, in the next iteration, min is set to that value, right? And on and on and on we go. So that's how it works, roughly speaking. There we go. So, questions. You could just use the min and max functions to code this. Yes, absolutely. You know, it's kind of funny, but the sort of smart aleck way to write this is to do def min max t is return min t comma max t, because Python already has built-in functions to find the minimum and the maximum. That's not the point of this. You know, the point is to show you how an algorithm goes from flowchart to program. But yeah, min max 2, and you'll see that you can print min max 2 and get the same result. Same result twice. Ta-da! There you go. Yeah. You can use for loops as well, but we're going to get to for loops eventually. So, gonna skip that. Gonna skip that. Gonna skip that because we did it in code, so that's better. So, what's going to happen if there are two min values which are the same? Well, that's a good question, actually. So if there are two min values which are both the same, like, for example, if there was a 1 here as well, this condition is only executed if ti is less than the minimum. So in effect, what's happening is min keeps the old value if there's a tie. If we wanted to change that for it to keep the new value if there's a tie, we would say less than or equal to. But since they're both the same gosh darned number, it doesn't matter. And this is slightly faster because it saves like 1 step of execution. So here's a question. I declared the list t after implementing the sorting algorithm. Why does this not throw an error? Because I'm still defining... So I've defined the function, right? I've defined this this list, but I've only used the function down here, right? So the function does not get like this t and that t are different t's, right? The function doesn't execute until it's been called, and this is not calling the function, right? So we can actually call this as many times as we want on as many different pieces of data as we want. But yeah, you should kind of in your mind draw a distinction between the stuff that's up here, and the stuff that's down there. This is just saying what stuff is and does. This is the actual execution. So there you go. There you go. Does the length function start counting from 1 or 0? Well, that's a good question. Let's pull that up in the interpreter. What is the length of 1, 2, 3? Or 1, 2, 4? The length of this is 3. So length is the number of elements. It is the cardinality. The function does not throw... Yes. So, let's talk about programs. Programs. We're gonna have some more talky bit, and then we're gonna do some more. Yeah, the rest of these slides are talky bits, so we're gonna do more code examples, probably minimally next time in class. So, programs. Programs are algorithms that can be executed automatically by a computer. This is a picture of the Manchester Mark I, which was one of the earliest computers. Fixed program computers serve only one purpose. Some early computers, digital clocks, washing machines, these are all fixed program computers. Stored program computers, on the other hand, store the program as a sequence of instructions in some kind of memory. The instructions can change. It is a more general type of machine, right? So, one of the first modern stored program computers was the Manchester Mark I, which was built in 1949. So this is not the one that this is not the one that Turing built to beat the Nazis. So, because the program in a stored program computer can be changed, this means that you can write programs to modify other programs. This allows us to have things like the Python interpreter. So, the way that they achieved this was by storing the instructions in the same format as the data. So the instructions are a form of data that the computer can operate over. This was an implementation of the quote-unquote universal machine, which was anticipated by Alan Turing in 1936. So, this is a view of the von Neumann computer architecture. This is the computer architecture that most computers will use across everything. The only types of computers that don't use this are some of the weirder hardware design type systems, which, are very interesting, but, pretty much everything will use this model of computation, with certain rare exceptions. So, the way a computer works. You have the computer itself. The computer is divided between the central processing unit, or CPU, and the memory unit. The central processing unit contains a control unit and an arithmetic logic unit. The control unit is only responsible for moving memory around. So it gets memory out of the input devices or out of the memory, and it gets data, out of the input devices or the memory, moves it into the CPU. The arithmetic logic unit then performs operations over this data. Things like addition, subtraction, multiplication, division, all of these beautiful mathematical operators are performed by the arithmetic logic unit. Then, once the ALU is finished operating on the particular data, the control unit places that information either back in memory or to an output device. Of course, input devices are things like your mouse and keyboard, and output devices are things like your screen and printer and speakers. So, yes. CPUs operate on bits. Bits are sequences of ones and zeros. If you didn't know this, this is kind of cool. Inside of your computer's electronic circuitry, what distinguishes a 0 from a 1 is the level of voltage at which that circuit is kept. So high voltages are typically something like 5 volts DC, and that characteristically represents a 1, or an on state. 0 is 0 volts, as one might expect. That characterizes an off state. So these individual elements of memory, these ones and zeros, are collected in vast quantities to produce everything that you see in your modern computer system. I do not answer questions, will this be on the test? If you aren't, you have to be clever enough to figure out if this is going to be on the test. Yeah, what am I going to say? No, you don't have to pay attention to anything I say for the next 10 minutes. So, CPUs also contain their own limited memory called registers, but most memory is stored either in the random access memory, or RAM, which is RAM chips. So when you refer to your computer as having X amount of RAM, or X amount of memory, like my computer has 16 gigabytes of memory, normally you're talking about RAM, random access memory. The other type of memory, which is not normally referred to as memory, it's normally referred to as disk space. This is your ROM, read-only memory. So this is your hard drive. This is where your file system is. Are registers also the cache memory? No. Cache memory is usually not stored in registers. Registers are the lowest possible state of memory. They're the closest, they're actually inside of the CPU itself. You can have caches that are inside of the CPU, but they're larger memory cells. So, programming languages. Fortran, an early high-level language from 1958, was called Formula Translator and was for expressing mathematical expressions in machine language. This is how you used to program in the 60s. You would have a stack of punch cards. So this is how it would work. You would open up your box, you would get your sheath of blank punch cards, you would take a hole punch, and you would punch your program into your punch cards. And if you are smart, you would write on your punch cards you would write a number in the sequence on the punch cards, so that if the punch cards got out of order, you could put them back in order. But it was an extremely laborious process. Registers are temporary storage. Sort of. But, yeah. So, you're too early. You're too early to know what a register is. In order to know what a register is and really does, you really need to study computer architecture. But rough sketch. The registers are what the So the registers, so you remember there's the control unit and the arithmetic logic unit. The control unit loads the registers. The arithmetic logic unit operates on the registers. Then the control unit unloads the registers. So the registers are the memory that is actually being acted upon by the arithmetic logic unit. That's what a register is. So, oh, did I skip this? No, I just explained it in different ways. Another thing you can do is jump to different instructions based on the value of data in a register. So if you imagine your program as a series of instructions, you have inside of the CPU what's called the program pointer. The program pointer points to the currently executing instruction, and you, as you execute instructions, the program pointer indicates subsequent instructions in your formula. Yes. So, starting with ALGOL and Pascal in the 60s and 70s, programming languages became closer and closer to algorithmic notation. While graphical programming languages have dedicated use, textual languages are dominant for large programs. In general, the way that people program these days is the way that I am showing you to program here. So, yeah. My goodness, that's a lot of comments. I'm going to... So this is the official end of class. I will now answer a few questions, but I've got another class, so I've gotta keep this quick. So this is quick fire. How many arguments can we put in an if statement? If statements don't have arguments, functions have arguments. Did Alan Turing's universal machine use these programming methods? No. Turing's universal machine was a conceptual machine. It was an abstract machine. It wasn't a physically implemented machine until he made his physical machine. But his physical machine was a, I believe it was a fixed program computer because they were specifically trying to break the Enigma machine. So, in Python, okay. What will the tutorials be like in person? You will just have to go and see. All right, take her easy, folks. I'm going to log off here. Have fun in the rest of your class today. Bye-bye.